Hello again, Year 12. Right, let's go through the paper two. You did the paper one a couple of weeks ago, which was the mechanics and electric circuits. And here's the paper two, which is the with the waves and the materials. Right, I thought this was okay. I thought this paper was pretty straightforward. Pretty much all the applications I thought were as straightforward as they're going to get. And a lot of it was kind of recall of knowledge. I thought it was pretty nice paper. This, so I think if you really struggled with this, then we really need to go through, key areas of knowledge and understanding in the content. Anyway, let's have a little look at. So let's look at questions 1 to 5 on the multiple choice. First up, right. First question in was materials, and it's pretty much recall. This is knowledge recall. So let's talking about a stress strain graph for steel, and it wants to know which of the following describe or best describe the elastic limit. Right, you need to know these. You need to know all the key terms within like Young modulus, within deforming solids, and especially things like ductile, breaking stress. All those you need to learn those off by heart. So let's have a look at this now. This is a typical stress strain graph, which if you remember, is the same as a force extension graph. It's the same shape and it's the same points on it. But the first part, this is where our sample obeys Hooke's law. Now, Hooke's law is when force is proportional to extension or stress is proportional to strain. So that goes straight line. Now, when it's no longer proportional, you've then gone beyond not the elastic limit. You've gone beyond the limit of proportionality. This section here is still elastic. Okay, if you were to let go or if you were to unload, you would always go back to the same point. All right. Now this is the elastic limit here. If you go beyond the elastic limit, when you unload, you would have a permanent deformation. Okay. So the elastic limit is the point at which you go beyond. You will have a permanent deformation. The material will show plastic behavior. So that question is clearly number C. It's all about it being permanently deformed. Okay. Question 2, radar. Okay, what's it using here? We're using microwaves, but it's echolocation. It's figuring out how far something is away by bouncing waves off it. Now in this case, it's microwaves. How fast do microwaves travel in air? The speed of light. So 3 times 10 to the 8 is our speed of light. So speed is 3 times 10 to the 8. Okay. Now, the time in seconds between emission and reception. Right. We want one of these four. Okay. One of these four gives us the distance. The distance from the transducer. A transducer is something that can give off and receive energy. It can give off and receive a wave signal. Okay. So we want the distance from the transducer to the aircraft. Now, speed is a distance over time. So distance is speed times time. Okay, but don't forget this distance here is there and back. So if we want the distance just to the aircraft, we have to divide by 2, don't we? So there you have it. That's C. Okay. Question number 3. Spectra. Okay, energy levels in an atom and spectra. During which transition is EM radiation with the shortest wavelength emitted? Right, if it's emitted, it must be an energy transition from high to low. Okay, because energy must be lost by the electrons, so therefore photons are emitted. So now the one with the shortest wavelength, short wavelength means high frequency. High frequency means high energy. So the one that's a drop with the highest energy is D. Question 4, Hooke's law equation. Which of the following gives the base units of K? Now, it's very common to go Units of K, yeah, units of K are newtons per meter. Boom. C, no. All right, always look out for that. They do that all the time. They sneak in base units. All right, and they always have the standard units, rather the standard units there as one of the options. So base units. Right, let's look at this. But the standard unit of K, as we know, okay, square brackets means units of. The standard units of the spring constant are newtons per meter. But as we know, because force equals mass times acceleration, 1 newton is 1 kilogram, meters per second squared, m to the minus 1. The m and the m to the minus 1 cancel, leaving behind kilograms s to the minus 2. Which one's that? It's A. Okay. Question 5. Total internal reflection. All right. The two criteria for total internal reflection are the incident ray has to hit the interface at an angle greater than the critical angle. That's the one criterion that everyone remembers. The second criterion, which people always forget, is medium 1 has to be more optically dense than medium 2. Okay? Say this was um, um, air going into water. Say this was air and this was water, you could not get TIR. You would get some reflection, but you'd always get some transmission into the medium. So for TIR, for total internal reflection, right, this has to have a medium 1 has to have a higher refractive index than medium 2. Okay, so that's why if this was water and this was air, you always get TIR, don't you? Okay, right. So there we have the first criterion which I've just mentioned, which is okay. N1 has to be greater than N2. The refractive index of medium 1 has to be greater than the refractive index of medium 2. Now, it wants the speed as well. Okay, which media is light traveling fastest? It travels fastest in a vacuum, and it travels almost as fast in air. So if it's got a high refractive index, okay, it's got a low speed. The higher the refractive index, the more light slows down. So here we have V1 less than V2. Okay, so V1 less than V2, we can have B or D, but it looks like it's that one. Okay. There we have N1 greater than N2 and V1 less than V2. So the answer to 5 is B. Okay, there you have questions 1 to 5. Next video, I'm going to do 6, 7, 8. Thank you very much.